Hi guys, good evening. The next topic is irrational. So, before defining the irrational, first let us consider some decimals. Like the first decimal number is decimal 10, 100, 1 triple 0, 1 4 times 0, 1 5 times 0, 1 and so on. Similarly, next decimal is decimal 20, 200, 2, triple 0, 2, 4 times 0, 2, 5 times 0, 2 and the next one is decimal 30, 3000, 3, 3 times 0, 3, 4 times 0, 3, 5 times 0, 3 and next one is decimal 1211, 2 triple 1, 2, 4 times 1, 2, 5 times 2, 6 times 1, 2 and so on. So, by the simple observation in the following decimal number, these decimal numbers are non-terminating, non-recurring decimal, or these are also known as non-terminating, repeating decimal. So, what is the definition of irrational number? So, now we will write the definition of irrational number. So, a number is irrational if it is non-terminating, non-recurring. A number is irrational if it is non-terminating, non-recurring decimal or non-terminating, non-repeating decimal is known as irrational number. Similarly, in the simplest way, it can be also defined as a number is irrational if it cannot be expressed in the form of P upon Q, where P and Q both are integer and Q cannot be equals to 0. So, irrational number can be expressed or defined in two forms. A number is irrational if it is non-terminating, non-recurring decimal or non-terminating, non-repeating decimal is known as irrational number, or a number is irrational if it cannot be expressed in the form of P upon Q, where P and Q both are integer and Q not equals to 0. If a number which can be expressed in the form of P upon Q, then it will be termed as rational number. So, some example of irrational number are, for example, the irrational are root 2, root 5, root 7, pi, that is 22 upon 7, which is the approximation of pi. Sometimes it like as p by q form, but pi is never rational, it is always irrational. Now we will prove some irrational number. So let us consider, first prove that root 2 is an irrational number. So how we will prove? If a given number is irrational, then question first, prove that root 2 is irrational number. To prove root 2 as irrational, first of all, we will consider that root 2 is a rational number by assuming that root 2 is rational number, and in this method we will take it as a contradiction. So by the method of contradiction, if it is possible, first of all we will consider that root 2 is a rational number. So let root 2 is equals to p upon q, where p and q both are integer and q not equals to 0. So what we are assuming here, by the method of contradiction, if it is possible, let us consider that root 2 equals to p by q, that is root 2 is a rational number by the contradiction we are considering. So let root 2 is equals to p by q, where p and q both are the integer and q not equals to 0. Now squaring on both sides, so 2 will be equals to p square upon q square, implies that p square is equals to 2q square, implies that p square is an even number, implies that p is an even number. Here, if p is not an even, here if p is not an even, if p is not an even, then p is equals to 2m plus 1, let, where m belongs to z, m is any integer, implies that p equals to 2m plus 1 is an odd number. Now squaring on both sides, p square equals to 2m plus 1 whole square, implies that using a plus b whole square, p square is equals to a square, that is 4m square, plus b square, that is 1, plus 2ab, that is 4m, which is which is an odd. So this contradict that P is an even number. Now let P is equals to 2m. Now let P is equals to 2m where m belongs to z. Squaring on both sides, P square is equals to 4m square. P square is equals to 4m square. But by the equation number first, P square is equals to 2q square. So by putting in equation number second, P square is 2q square. So 2q square will be equals to 4m square. Implies that q square is equals to 2m square. Implies that q square is an even number. Implies that q is an even number. Implies that by the equation number first and second, P and Q both are even number. Implies that if P and Q both are even number, then P and Q both are having common factor other than 1. Other than 1. This contradict that they have no common factor other than 1. So our assumption implies that our assumption was wrong, or it contradicts with our assumption that root 2 is rational. Implies that root 2 is irrational number. In this way, we proved that root 2 is irrational number. Now, one more example we will take. Prove that, next question. Prove that root 3 is irrational number. So again, to prove that root 3 is irrational, by method of contradiction, first of all, we will consider that root 3 is rational. If root 3 is rational, then it has only one common factor, that is 1. So, by the contradiction method, we will assume that by the method of contradiction, Let us assume, if possible, that root 3 is rational. If root 3 is rational, then root 3 can be expressed as the form of P upon Q, where P and Q both are integer and Q not equals to 0. Now, if root 3 is equals to P upon Q and P and Q both are integer and Q not equals to 0, then P and Q having the common factor as a 1. So, squaring on both sides, root 3 square will be 3 and P upon Q whole square, that is P square upon Q square, implies that P square is equals to 3Q square, implies that P square is an even number, implies that P is an even number. Here P and Q both are integer and they have no common factor other than 1. So let, if P is not an even, then P equals to 2m plus 1, where m belongs to z, implies that P is an odd. Now squaring on both sides, P square will be equals to 2m plus 1 whole square, implies that P square will be equals to 4m square plus 4m plus 1, which is an odd number, which contradict that P is an even number. Now let P square is equals to 2m P square, P is equals to 2m, squaring on both sides, P square is equals to 4m square. By equation number first, P square is equals to 3q square. So 3q square is equals to 4m square, implies that q square will be 2m square, implies that q square is an even number, implies that q is an even number, implies that P and Q both are even number, which implies that P and Q both have common factor other than 1, which contradict with our assumption, which contradict of our assumption that root 3 is a rational number implies that root 3 is an irrational number. So, it was about the irrational number, and if any number is given that it is irrational, then how we will prove that the given number is irrational. So this topic is very important topic. So hope you like this video. Please like it, share it and subscribe to get next video in continuation. Thank you all of you.